Okay, I'm going to do a video going over the evens of the review packet. So power to a power, we multiply. So this will be a to the -9, b to the 6th, over a to the 2nd, b to the -10. Reminder, when you're dividing, you're going to subtract the exponents. So this is going to be a to the -9 minus 2, and b to the 6 minus -10. So this is a to the -11, b to the 16. b to the 16 will stay on the top because it has a positive exponent. A to the -11 flips to the bottom and then becomes a to the +11. Next one, 9/3, I would reduce to 3/1, and then I will raise everything to the -3rd, so it'd be 3 to the -3rd, x to the 3rd, y to the -6, over x to the -3, y to the 9. Then we will subtract exponents. Well, first of all, 3 to the -3rd is 1/3 to the +3rd. X to the 3 minus -3, and y to the -6 minus 9. So it's 1/27th, x to the 6th, which will go on top. And this is a y to the -15, which then I'll flip to the bottom and become y to the +15. 6, power to a power. Again, we're going to multiply. Okay, we get a to the 6, b to the -4, c to the 0. This one actually is pretty nice because a to the 6th over a to the 6th cancels to 1/1. C to the 0 is 1, so that's just times 1. So really all we have is b to the -4 minus -9, right? When we're dividing, we subtract. So -4 minus -9, which is b to the 5th. Number 8 is taking 4m and raising it to the 0 power. Anything to the 0 power is 1. 9 to the -3/2 is 1/9 to the +3/2. So you flip the base, exponent becomes positive. So that means the square root of a 9th cubed. So square root of a 9th is a third cubed is 1/27th. So this is 1 plus 1/27th, or 1 and 1/27th. Cubic root. So we're going to have to break it into 2 cubic roots. 64 is a perfect cube. X to the 9th is a perfect cube because 9 is divisible by 3. 5 is not divisible by 3, so we are going to have to make this y to the 3rd and y squared. Y to the 3rd times y squared is y to the 5th. So that's the closest number that's divisible by 3 is 3. So that's our perfect cube. So this is 4x to the 3rd y, and then cubic root of y squared stays under that radical because it's not a perfect cube. Subtracting radicals, we need like radicals. So we're going to break these down, see if we can get like radicals. 18, 9 is a perfect square. 9 times 2. X to the 4th is a perfect square. So this is 3x squared, radical 2. 72, 36 times 2 gives us 72. X to the 4th again is a perfect square. So this is minus 6x squared, radical 2. So we can subtract the coefficients, get negative 3x squared, radical 2. So like radicals. 14, you are going to multiply by the conjugate. Okay, so we're going to multiply by 2 minus 3 radical 5. On the top, we are going to FOIL. So 4 minus 6 radical 5 minus 2 radical 5 plus 3 times 5. On the bottom, first is going to be 4. Outer would be minus 6 radical 5. Inners would be plus 6 radical 5. Last would be minus 9 times 5. So on the top, we've got, let's see, we got 4 plus 15, which is 19. So 19 minus 8 radical 5. And on the bottom, we've got 4 minus 45, which is negative 41. The middles cancel. So that is our answer. 16, we have to write this out twice in FOIL. So 9x squared minus 21x minus 21x plus 49. So that's 9x squared minus 42x plus 49. 18, going to need a common denominator. So that'll be x minus 1, x minus 2. So the first one has the x minus 1. It needs the x minus 2. So this is going to be the x minus 2. This one's going to need the x minus 1. So this is 4x minus 8, 3x minus 3. So just a reminder, with adding and subtracting, you do distribute through the numerators. This is 7x minus 11 over x minus 1, x minus 2. So that is our common denominator. Okay, multiplying, we factor everything, right? Because we normally multiply straight across, but we can reduce if we have some common factors. So everything's going to get factored. X, what multiplies to 2 that adds to 3 is 2 and 1. X plus 1, x minus 1, that's a difference of 2 perfect squares. Multiplies to 1, adds to 2 is 1 and 1. And then for the last one, multiplies to negative 2, adds to 1. So that'd be 2, 1, plus 2, minus 1. So that it adds to positive 1. All right, so let's see. The x plus 1 cancel. The x plus 2 cancel. And then we have an x plus 1 squared on the top. We got an x minus 1 squared on the bottom. So that is our answer. 22 is dividing fractions. So when we divide fractions, we're going to do our keep, change, flip, or multiply by the reciprocal. I'm going to start factoring as well. So I pull out an x. Multiply by the reciprocal. I'm going to pull out a 4 as I'm flipping that second fraction. 4 minus x and x minus 4 cancel to a negative 1 over 1. I'm left here with a b on the bottom. I'm left with an a on the top. So I have negative ax over 4b. 24 is a synthetic division because we're dividing by a degree 1. We get 3x squared, 5y, negative 2. Bring down, multiply, add going down, multiply, add going down. 3x minus 8 plus 6, which is our remainder over the divisor. 26 is a long division, so we got x squared plus x plus 1 into x to the 4th, no x cubes, minus x squared, no x's, plus 1. So we do have to hold those places. Okay, so what times x squared gives me x to the 4th? That would be x squared. So we get x to the 4th plus x cubed plus x squared. Subtract going down, so that's minus, minus, minus. Okay, so 0 minus 1 is a negative 1 x cubed. Negative 2x squared. Bring down the plus 0x. What times x squared gives me a negative x cubed? That would be a negative x. Negative x cubed. Negative x squared. Negative x. Subtract going down. So it's plus, plus, plus. Minus a negative will go to plus. This is negative x squared. 0 plus 1 is a plus 1x. Bring down our plus 1, and then we do it one more time. What times x squared will give me negative x squared? That would be a negative 1. Negative x squared minus x minus 1. Subtract going down. That's plus, plus, plus. 2x plus 2. So my answer is x squared minus x minus 1 plus the remainder over the divisor. Okay. And finally, we have our last page with the factoring. 28 has a GCF, so you pull out a 2, get x squared plus 81. That is then a sum of two perfect squares. So sum of two perfect squares, we factor just like a difference of two perfect squares, and that we put plus, minus. Square root of x squared is x. So we put x and x. This will have to be a 9i and a 9i. So with sum of two squares, you need the i's in there. 30, same thing, sum of two perfect squares. So plus, minus, 2x, 2x, 9i, 9i. 32, it's a tricky one. We've got a 1 by 3 grouping. This is almost a perfect square trinomial. If I factor out the negative, then I do have a perfect square trinomial. So I can write it as a binomial squared, x plus 7 squared. So now it's just factoring a difference of two perfect squares. So y, x plus 7, parenthesis x plus 7, because again, it's following a subtraction sign. So this would be y plus x plus 7. This is y minus x minus 7. That's just distributing my negative. 34 is a 2 by 2 grouping. Factor out the y, get x squared minus 1. Factor out the negative 7, get x squared minus 1. Factor out the x squared minus 1 and get y minus 7. So you're pulling x squared minus 1 out of both of those. And then this is x plus 1, x minus 1, y minus 7. So x squared minus 1 is a difference of two perfect squares. So you factor it to x plus 1, x minus 1, and then you have the y plus 7. 36 is a difference of two cubes. So a is the cubic root of 125m cubed, which is a 5m, and b is the cubic root of 1, which is 1. So then we go a minus b, a squared plus ab plus b squared. So that's my answer for 36. And then finally, last one, 38, is another 2 by 2 grouping. We pull out the x squared, we get x minus y. We pull out the 11, we get x minus y. We pull out the x minus y, get x squared plus 11. That's it. All right, that's it for the evens.